So today we're going to talk about the properties of real numbers. Now, properties are kind of like rules for using real numbers. So these are rules, properties that we know are true when we use real numbers. So we start with our properties by saying, for all real numbers, a, b, and c. So that means if I have three numbers, a, b, and c, that are real numbers, this is going to be true for them, no matter what they are, as long as they're a real number. So the first thing we have is that a plus b is going to be real and unique. So if I take a and I take b, and they're both real numbers, I'm going to get one real number, which is their sum. Likewise, if I take a times b, I'm going to get one real number that is unique. So I only get one answer. And if you think about it, 2 times 3, your answer is 6. 6 is a real number, and you can't get 2 times 3 to be equal to anything other than 6. So we call this property closure. Closure means that it's kind of closed and inside. You don't have to go outside the circle of real numbers if you're going to do a plus b or a times b. So our first property of real numbers is closure, and that means that a plus b is real and unique, and a times b is real and unique. The next property is that a plus b equals b plus a, and a times b equals b times a. So order doesn't matter. And do you remember, I'm sure you've learned this property, do you remember what this is called? When order doesn't matter? Well, it's commutative. So it doesn't matter which order we put these in, we're always going to get that same unique real number. So our second property of real numbers is the commutative property. Order doesn't matter. So this third property says that if I group a and b and add them together and then add them to c, it's the same as grouping b and c and adding them together and then adding them to a. Or for multiplication, if I do a times b and then multiply by c. Or if I do b times c right here and then multiply by a, it's going to be the same answer. Now I have to be careful. It can only be all addition or all multiplication. I can't combine them. But that means that grouping, the groups do not matter. And do you remember what that's called when your groups do not matter? Well, it doesn't matter who they associate with, so we call it the associative property. So the associative property of real numbers says that when I have addition, I can group them however I want and still get the same answer. And when I have multiplication, I can group them however I want and still get the same answer. As long as the catch is, it's either all addition or all multiplication. Our next property for all real numbers says that a equals a. So anything equals itself. And think about looking in a mirror. You see yourself, don't you? You see your reflection? Well, this is called the reflexive property. And that just means that the number equals itself. Our next property says that if a equals b, then b equals a. So if a equals b, then b equals a. And this is called the symmetric property. And if you think about symmetry, it usually means that you can flip something around and it'll look exactly the same. So if you think of a circle, if you have a perfect circle, you can flip it over and it's going to look exactly the same. And so that's symmetry, and this is the symmetric property. If a equals b, then b equals a. So our next property says that if a equals b and b equals c, then a equals c. So this is called the transitive property. And if you think about it, it's almost like we transition. We go from A to B, and then, since B is over here as well, we go from B to C. It could also be kind of like substitution. You're substituting C in for B. But as far as properties go, we name this one the transitive property because we can transition from A equals B and B equals C straight down to A equals C. Our next property says that A plus 0 equals A and 0 plus A equals A. So you add 0 to a number and you get that number back. And we call this the identity property of addition, because we are only talking about addition here. So the identity is the number, in this case, that we add to get the same number back. And so that's 0, because anything plus 0 is going to give you the same number you started with. So the identity property of addition is a property of all real numbers, because if you add 0 to any real number, you're going to get that same number back. So our next property says that A plus the opposite of A equals 0, or the opposite of A plus A equals 0. And so I said opposite instead of negative, because what if A was negative? So if I had negative 2 plus the opposite of negative 2, would that give me 0? Well, that's negative 2. What's the opposite of negative 2? Positive 2. And what's negative 2 plus 2? 0. So we call this property that says if I add the opposite, I'm going to get 0, the property of opposites. So it's the property of opposites. And we actually have a special name for A and negative A, or A and the opposite of A. A and negative A are called additive inverses. And all that means is that if you add them together, you get that 0, which remember was the identity property. If we added 0 to a number, we got itself back. So these are called additive inverses, because if I add A to negative A, I get 0. So it's like doing the reverse of what I was doing. And we're going to be using that a lot when it comes to solving equations without having to plug numbers in. Alright, so our last property for all real numbers says that if I take the opposite of A plus B, it's just like taking the opposite of A plus the opposite of B. And so we call this rule the opposite of a sum. That's the property. And I want us to take a look. So if I have negative 2 plus 5, well, first thing I want to do is 2 plus 5 is 7. So the opposite of 7 is negative 7. But now I want to test our theory. Is that like negative 2 plus negative 5? Well, what's negative 2 plus negative 5? Negative 7. So indeed it does work. So the opposite of a sum says that I can go from taking the negative of a sum and making it the sum of the negatives, or the opposites. Alright, so now that you know the properties, why don't you go take the check-in, and then we're going to do some practice problems and build some on this in class.